Hello everyone, welcome to e-learning session of Basics of Electrical Machine in which we will discuss the DC motor. This is the topic of subject Basic Electrical Engineering. The electrical machine is a device that converts the mechanical energy into electrical energy and electrical energy into mechanical energy. The machines which are operated in relation with electrical energy are called electric machines or electrical machines. In electrical machines, either input, output, or both can be electricity. This is a classification of electric machine where electrical machines are mainly classified into two categories. First one is static machine and second one is rotating machine. The static machine is such kind of machine which does not have any moving part and they remain stationary throughout in operation. The transformer is a stationary electrical machine which does not have any moving part. It is a machine because there is a conversion between electrical and mechanical energy between the windings of transformer. Second one is rotating machine or dynamic electrical machine. Such type of machine consists of moving parts as well as stationary part. Again, rotating machines are classified into two categories, DC machine and AC machines. The electrical machines are divided into two categories, electric motor and electrical generator. DC machine consists DC generator and DC motor. The electrical energy is produced in the form of a generated voltage or EMF. If this EMF is constant, the machine is called DC generator, and while if it is alternating, the machine is called AC generator. When the electrical input energy is converted to a mechanical energy, then the machine is called a motor. And if the electrical energy is in the form of DC voltage, it is called DC motor, and if it is in the form of AC voltage, it is called a AC motor. Thus, various electric rotating machines are classified as AC machines and DC machines. AC machines are again divided by in two categories, synchronous machines and asynchronous machine. Synchronous machines and electrical machines whose rotating speed is proportional to the frequency of alternating current supply and independent to load called the synchronous machine, while asynchronous machine in an electrical machine in which the magnetic field and the rotations are not exactly same is called the asynchronous machine, while the machines accepting input from AC supply to produce mechanical output are called the synchronous motor. The asynchronous machine is again induction machine. Induction machine is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the starter winding. The synchronous generator, synchronous motor and induction machine, all three are divided into three categories, a single phase and three phase. Depending upon the type of phase, it may be single phase and three phase. Now, introduction to DC machine. The rotating electrical machines are electromechanical energy conversion devices that converts mechanical power into electrical power or electrical power to mechanical power. There are two types of DC machines. First one is DC generator and second one is DC motor. A DC generator converts the mechanical power into DC power, whereas the DC motor converts the DC electrical power into mechanical power. This is the principle of operation of DC machine. The principle of operation of DC machine is based on the principle of electromechanical energy conversion, that is either from electrical energy into mechanical energy or from mechanical energy to electrical energy. A DC machine consists of a system of conductors called armature, which is placed on the movable shaft, and a system of electromagnets called the field system, which is stationary and produce required magnetic field from the operation. The basic concept is that when a current carrying conductor placed in a magnetic field, it experiences a force that tends to move it electrical energy into mechanical energy. This is the action of motor, where current carrying conductor at the magnetic field gives the rotation of free part. Now, for in the case of generator, if an electrically externally applied force makes the conductor to move in the magnetic field, the current starts to flow in the conductor, thus converting mechanical energy into electrical energy. This is action for generator, where conductor rotates at magnetic field and gives the current in generator. Now come to the basics of DC motor. DC motor is a machine which converts electric energy into mechanical energy. It works on the principle of Lorentz law, which states that when a current carrying conductor is placed in magnetic field, it experiences a electromagnetic force, also called the Lorentz force. The magnitude of this force is calculated by the formula F is equals to BIL, where B is the flux density of the magnetic field, I is the current flowing in the conductor, and L is the length of the conductor. Now, the direction of force which determine which direction the motor spin depends on two factors, that is the direction of the current in conducting wire or the direction the magnetic field. The direction of this force is governed by the Fleming left hand rule. According to Fleming left hand rule, if we stretch the thumb, forefinger and middle finger of our left hand such that they are mutually perpendicular to each other, and if forefinger points to the direction of flux, middle finger points to the direction of current, then the thumb gives the direction of force. This is shown in figure, where our thumb represent the force, index finger represent the magnetic field, and the middle finger represent the direction of current. This is the construction of DC motor. An electrical motor consists of a rectangular coil of insulated copper wires which is mounted between the curved poles of a horseshoe type permanent magnet in such a way that it can rotate freely between the poles south and north, that is S and N. The device which reverses the direction of the current through a circuit is called the commutator. The two ends of coil are soldered permanently to the two half rings of a commutator. The commutator rings are mounted on the shaft of the coil and they also rotate when the coil rotates. The armature is the rotating part which converts electrical power to mechanical power in the form of torque and transfer it via the shaft. So, the armature is placed between the north and south pole of the permanent magnet. This is the working of the DC motor. When an electric current is placed in the rectangular coil, the current produces a magnetic field around the coil as shown in figure B. This current develops their own field around the coil. The magnetic field of the permanent magnet interact with the magnetic field of the current carrying coil and causes to rotate the coil continuously. The field enter the force at the ends of the conductor. This field extract a force the end of the conductor and thus the coil start to rotating. Here M and A is magnetic neutral axis. Now let the field produced by the main field be Fm. and this field rotate in the clockwise direction. When the current flow in the coil, they produce their own magnetic field, say Fr. The field Fr tries to come in the direction of main field, therefore the torque act on the armature coil. The speed of motor is directly proportional to the number of coils used in the motor. These coils are kept under the impact of magnetic field. The one end of the conductor are kept under the influence of north pole and other one of the south pole. The current enter into the armature coil through the north pole and move outwards through the south pole. When the coil moves from one brush to another, at the same time the polarity of coil also changes, so the direction of force and torque acting on the coil remain same. The torque induced in coil becomes zero when armature coil is perpendicular to the main field. The zero torque means motor stops rotating. For solving this problem, the number of armature coils are used in the rotor. So if one of their coils is perpendicular to the field, then the other coil induces the torque and rotor moves continuously. Thank you everyone for watching my video.